Welcome to Code and Codes. Hi, I'm Salim Makandar, and in this series, I will be sharing the secrets, tips, and strategies to help you ace your AI interview. Whether you are just starting out or polishing your skills, I have got you covered with real world insight, must know topics, and expert advice to land that dream job in AI. So, from the coding challenges to key AI concepts, I will break down everything you need to know step by step. In my past experience, also, I cracked the interviews for most of the AI companies. Okay, so uh, so hit that subscribe button and let us unlock the path to your AI career together. Okay. So let's start with what and all the things actually we need to prepare. Okay, so here I created the some of the sections so which can be the part of our preparation. So these are the high level things, like I can say these are the sections where we need to prepare. Okay, so here I created such 10 sections. For example, the section 1 is the machine learning. Okay, so inside these sections again the subparts will be there, because in the one video I can't able to cover all the things, so I break down each of the section in the subparts. Okay, so first section is the machine learning, then next we will see the deep learning, then we will go through the basic NLP thing, then next is the generative AI, then after that the computer vision thing, then we will see the model optimization, then the pandas thing. So because some of the companies actually it is actually they are taking the interviews on data science, so on that I found some of the common questions actually they asked with respect to the pandas, so that we will see. And also the C++, it is also important, because the most of the companies they will ask mostly into the Python, and specifically for the C++, so that topic also we need to cover. Then the data structure, so that is also very important. And the last but not the least is the C and the basic OS. So this one is not that much important. Okay, but I having very good exposure on the C and basic OS, so I just included this thing, but you can skip this into the later session. Okay, so here we will start first machine learning section. Okay, so inside the machine learning I found out these are the topics. Okay, so actually I extracted more than 100 topics, okay, which is very important. And I found these are like the basic concepts actually we need to first clear, and we need to understand all of these things. Okay, so this is a very important thing, so please don't miss any of the topic from this machine learning thing. Okay, so now we will start the section 1, which is the machine learning. So in the part 1 I will try to complete this of the topics. Okay, so first is like what is the supervised versus unsupervised machine learning. Okay, then the linear regression with example we will see, like what is the univariate linear regression. Then the hypothesis thing, like how the hypothesis actually will be there inside the linear regression. Then the cost function in the linear regression, gradient descent in linear regression, why gradient descent work, the intuition behind actually we will see. Then the choice of alpha and the convex function we will see. Then we will see the multivariate linear regression with gradient descent. Okay, so let's start our first topic, which is nothing but this supervised versus unsupervised. Okay, yeah, so here first we will see what is actually the supervised machine learning. Okay, so inside the supervised machine learning, okay, we having the training data set. Suppose we having the training data set which including the example from 1 to example from the yum. Okay, so inside the supervised machine learning, for each example it having the respected label which is denoted by y1. Okay, so for the second example also it will have the respected label which is denoted as the y2. In a in this way, for each of example it will have the label, okay, ym. Okay, so the supervised machine learning is nothing but like whatever the training data you having, so inside for each sample or for each example it must have the label y. Okay, so if I give the real-time example of the supervised machine learning, so we will take the example of the classification like cat and dog classification, where you having the data set of the images from the one image to the yum image. Okay, so where in each image you will having the label for that image either cat or dog. Okay, in the same way for each image you having this thing. In the same way for whatever the last example also will be there, whatever the last image you having the label cat or dog. Okay, so simply this is the supervised machine learning where for each example you having the label. Okay, so what and all the examples of this supervised machine learning? So as I said, the classification is one of the example. Okay, then regression is also one of the example. Okay, either it is the univariate or the multivariate regression, so that is also the example of the supervised machine learning. So like that many more examples are there. Okay, now let's see like what is the unsupervised machine learning. Okay, I will change the pen color. Okay, so inside the unsupervised machine learning, there also you having the data set where you having the examples from the first, second to the n examples you having. Okay, but the difference is that for any of the examples you not having the any label. Okay, so for any examples you don't having any label yi. Okay, so that thing is not there. Okay, so like then you having the question like how this kind of the unsupervised machine learning thing internally how actually it will work, because without label how it can able to learn the things. So whatever the data set you are feeding to the unsupervised machine learning algorithm, it will see like what is the pattern of the data. Okay, so and it try to create the clustering from that. Okay, and whatever the features you are providing, it will try to find out the patterns from that. Okay, and from that pattern it will create the different cluster, or it can able to extract the insights from that particular patterns. Okay, so if I give the real-time example of the unsupervised machine learning, so suppose you having suppose if I give the example of the advertisement clustering. Okay, so at that time suppose you may having one web page. Okay, and for that particular web page, so the different kind of the customers actually interacting to the web to that web page. Okay, so different kind of the customer they will interact to this web page. Okay, So this customer having the intention to interacting to this web page, like some of the customer having the intention of the entertainment, or some of the customers having the intention of the learning, or some of the customers having intention of the productivity. Okay, so at that time whatever these interactions actually they are making, so that interaction, it will get saved in the form of the features. Okay, and with these features, and these features are getting fed to the unsupervised machine learning algorithm, and from this feature this algorithm will find the patterns, and it can able to create the different segments of the customers, like who is belonging to the entertainment, who is having the intention of the learning, or who is having the intention of the productivity. Okay, so this is I given one real-time example. Okay, but there are the different algorithms actually are there inside the unsupervised learning. For example, the k-means clustering will be there. Okay, principal component analysis will be there. Okay, and it is also used for the dimension reduction. Okay, so there are the different algorithms are also be there. Okay, so if I say what is the main difference between the unsupervised and the supervised, so inside the supervised, for each example we having the label y, and inside the unsupervised the labels will be not there. Okay, so this is with respect to supervised versus unsupervised machine learning thing. Okay, yeah, so now we can move to the next topic. Okay, so yeah, so our next topic is like what is the linear regression. Okay, and we need to understand the linear regression with example. Okay, so here we will see specifically what is the univariate linear regression. Okay, let me change the pen color. Okay, what is the univariate linear regression? Okay, so here term univariate means one. Okay, so the univariate linear regression means the linear regression with one feature only. Okay, sorry, with one feature. Okay, so first let's try to understand like how the regression thing will be work. Okay, so here I will give the example of housing price prediction. Okay, sorry for this. Yeah, okay, so suppose you having the training data. Okay, and in that training data you having only one feature, which is the size of house. Okay, and depending on this feature, so because of this is the supervised machine learning, so for each of the size of house we having the corresponding price of house. Okay, so suppose this is the y-axis and this is the x-axis. Okay, so here like each of, so this is the x-axis and this will be suppose y-axis. Okay, so here x-axis is nothing but the size of house into the feet square. Okay, and the y is price. Okay, price of the house. Okay, so in this data set we may having the different data points. Okay, for example, these are the data points. Okay, and this is suppose the size, the 10 feet square, 20 feet square, 30 feet square, 40 feet square, and suppose this is the price, like the $100. Okay, for sorry, $1,000, $2,000, $3,000. Okay, and for each of the size, okay, for each of the size we having the corresponding label. Okay, for example, for the 12 feet square, you having the corresponding price. It is suppose $1,100. Okay, so this is kind of the data we will having. Okay, and this is kind of the 2D representation of that particular data, which having only one feature, which is the size of the house. Okay, so now the linear regression, what actually it will do, it will try to find the best fitted linear line. Okay, best fitted linear line, which is represented by the linear equation. So this line will be the best fitted for this all this example. Okay, so here actually why I am saying this must be best fitted. Okay, so so like when you will means whatever the unseen data when you having, so when you will ask to model to predict the price of that particular data with respect to this best fitted line, so whatever the difference between that predicted price and whatever the actual label, it have to be minimum. So at that time we can say this will be the best fitted. Okay, so here we can say the job of the linear regression to find this best fitted line, best fitted line with respect to whatever the training data we will having. Okay, so this is the regression problem, because there are the continuous values of the x and we having the continuous values of the y. Okay, so I hope you get the idea like what is the linear regression, and I tried to given the illustration about with the example how actually it will be there. Okay, yeah, so now we need to find what is the hypothesis inside the linear regression. Okay, so here as I given the example. Okay, so here as I given the example, so the same example I will use. Okay, so in the x-axis we having the size of the houses, in the y-axis we having the price of the houses, and we having this particular data points. Okay, so linear regression, what actually it will do, so it will try to find out the best suited linear line, so that whatever the difference between the predictions and the actual label, that will be the minimum. Okay, so whatever this linear line will be there, okay, it can be represented as the linear equation. Okay, it can be represented as the linear equation. So that is nothing but because of here we are considering only one feature, so the linear equation for this particular line, it will become theta 0 plus theta 1 of x1. Okay, so x1 is nothing but whatever the features are there. Okay, so so whatever this linear equation is there, okay, so this is nothing but our hypothesis, okay, which is represented by h of theta of x. Okay, so this is the hypothesis. Okay, so whatever this hypothesis is there, inside that this theta 0 and this theta 1, it is called as the parameters. Okay, so theta 0 and theta 1 is called as the parameters. Okay, and this hypothesis is depends on these parameters only. Okay, because if we change this parameter value, then whatever the line we are getting, that may be different. Okay, so if I give the example, okay, for example if I give the example, okay, for example you having the 2D representation of your data, okay, and this is the value of x, which is nothing but the value of the feature, okay, and this will be the value of suppose y, okay, which is nothing but your label. Okay, so in this case, suppose if I give the theta 0 is equal to 0 and theta 1 is equal to 1.5. Okay, so my equation is like this: theta 0 plus theta 1 x1. Okay, so when x is equal to 1, okay, when x is equal to 1, so this equation will be become 0 plus, okay, theta 1 is 1.5 only, 0 plus 1.5 into x1, which is nothing but 1, which will q the 1.5. okay, so this will nothing but our suppose this point, okay, this point. Okay, then when x1 is equal to 2, so at that time the equation will be become 0 plus 1.5 into 2, which is nothing but 3. Okay, like this. Okay, so when the x is equal to 3, so that will become 1.5 into 3, which is nothing but 4.5. okay, so we will get the line something like this, right? Okay, so if I change these parameters values, okay, if I keep now, okay, if I keep now theta 0 is equal to 1.5 and the theta 1 is equal to 0, so at that time what will happen? Okay, so at that time here I will try to write the same graph. Okay, 1 2 3 4, and this one also 1 2 3 and 4. Okay, so now when x is equal to 1, so at that time what I will get? 1.5 plus 0 into 1, which is nothing but 1.5. okay, so I will get 1.5 somewhere here. Then when x is equal to 2, so at that time what I will get? 1.5 plus 0 into 2, where I will get again 1.5 only. then when x is equal to 2, then I will get the y is equal to, then I will get the hypothesis like this. Okay, so here you can able to see, like when I'm changing these parameters, the resultant hypothesis I'm getting the different. Okay, so because of that, the hypothesis like depends on the parameter. Okay, so in one of the interview actually they asked me like why the hypothesis in the linear regression or any of the thing is depends on the parameter. So at that time we need to give the explanation like this. Okay, so I hope you understand like what is the hypothesis. Okay, so this is the explanation about that. Okay, so now let's move to the next thing, which is what is the cost function. Okay, so as I said, means whatever you having your the data. Okay, you having your hypothesis, which is denoted by h of theta is equal to theta 0 plus theta 1 x. Okay, so this hypothesis is nothing but you are getting the predictions from here. Okay, you are getting the predictions from here. Okay, then whatever the predictions are there, okay, our objective is like it needs to be close to the labels. Okay, it needs to be close to the whatever the ground truths. Okay, so in order to evaluate that particular thing, like whether these labels, okay, whether these particular labels are and whether these predictions are close together or not, we need to evaluate this thing by using cost function. Okay, so this is nothing but the cost function. Okay, so this cost function actually denoted by the j of parameters. Okay, so in this case we having only the two parameters, which is the j of theta 0 and the theta 1. Okay, so this is called as the cost function. Okay, so it is used to order to evaluate whether whatever the predictions we are making and the labels that are in order to verify how much the difference in between them. So for that actually these cost functions actually we need to use. Okay, so yeah, so inside the linear regression, the most famous cost functions actually they are using, which is called as the square error cost function. Okay, so in the regression kind of the problem, these cost functions actually most of the popular, and the researcher also found like this cost function, with this cost function actually it is getting the better results. So you can able to see into the most of the linear regression problem, the square error actually they are using on that. Okay, so let's understand like what is the square error. Okay, so in order to understand this cost function, I will give some of the notations, so that actually we need to understand. Okay, so suppose you having the training data. Okay, and in that training data you having the example, okay, like the x1 x2 up to xm. Okay, so here this m is nothing but number of the example. Okay, so when I saying this x1 means the first example, when I'm saying the x2 means second example, if I say xi, so it is nothing but ith example. Okay, so in the same way, for each of this example we having the label y1, y2 up to ym. Okay, yeah, so the square error function, square error cost, it is defined as 1 upon 2m summation of I is equal to 1 to m. Okay, then h of theta xi, okay, minus yi square. Okay, so this function actually it is nothing but the square error cost function, where we are whatever this h of theta xi is nothing but, okay, let me use a different table, a different pen. This h of theta of xi is nothing but the prediction, this is the yi is nothing but the label, and we are subtracting this one, taking the square of that and taking the mean. Okay, so this is the mean square error cost function. Okay, and this 2m is actually in the formula itself they are using this constant 2 actually they are using, so because of that it is there. So in the one of the article I read, actually these 2 constant they are using in order to simplify the maths. Okay, yeah, so here this formula actually we need to keep in our mind. Okay, so the square error function formula is 1 upon 2m of summation of I is equal to 1 to m h of theta xi minus yi of square. Okay, so this is the cost function for the linear regression. Okay, yeah, so let's move to the next topic, which is nothing but gradient descent in linear regression. So as we saw in previous slide, so the cost function, it is helps to evaluate how our prediction is close to the ground truth. So it will give just what is the difference between the ground truth and the predicted values. So now the question is like how we can optimize this cost function, or how we can minimize the cost so we can able to get the predictions which is the close to the our ground truth. So at that time this gradient descent algorithm will comes into the picture. Okay, so this gradient descent algorithm, what actually it will do, so this will minimize our cost function. Okay, it will helps to minimize our cost function. Okay, so like what actually internally it will do, it will update the parameters. So means after a repeated process of that particular updation, whatever the predictions we will get in a such a way that it will close to the our ground truth. Okay, so if I illustrate by using the example, okay, so if I show you with the 2D graph, so suppose this is our y-axis where the cost will be there, this is our the x-axis where the thetas will be there. Okay, so this is the cost and this is the thetas, which is the parameters. Okay, and with respect to the thetas, we will get the cost is like this. Okay, so here is one term is called is the global minimum. Okay, so global minimum is such point where the cost is 0. Okay, so the goal of the gradient descent is to reach to such a cost which is optimal one, which is called as the global minimum, where we will get the cost with respect to that parameters is 0. Okay, so this is like the globe means whatever this gradient descent algorithm will be there, it will try to update these parameters in a such a way we will get the we can able to minimize the cost. Okay, so if I can write in the words like how actually the gradient descent will be work. Okay, so it is kind of the repeated process. So first step inside the gradient descent is like it will randomly initialize all the thetas. Okay, so whatever the theta values will be there, it will randomly initialize. Then this is the repeated process, actually it will be happen. Okay, repeat until coverage. Okay, it will happen. So why I'm saying the coverage, so coverage is like nothing but up to it will reach to the global minimum. Okay, so repeat until coverage. So internally it will update these thetas. Okay, and this update will be happen simultaneously. Okay, so in the word like we can say in this way. Okay, but the mathematically if I want to show you like how the actual algorithm will be there, so how we can represent. So okay, so in the same way I will write like 1 minute. Okay. Repeat until coverage. Okay, then what it internally what it will do mathematically, that I will show you. Okay, so first like how the hypothesis we can able to find. So h of here I will write hypothesis thing, h of theta x is equal to theta 0 plus theta 1 of x. Okay, so here if you can see, this hypothesis is nothing but the prediction for whatever example we are feeding in the x. Okay, and as I said, depending on this hypothesis we will get the predictions, and this hypothesis depends on these two parameters, which is the theta 0 and theta 1. Okay, so the gradient descent what will it will do, it will update these two parameters. Okay, so here I'm giving the example of the univariate linear regression. So because of we can able to see only one theta 1. Okay, means theta 1. Okay, so how it will, what it will do, it will update this theta 0 first. Theta 0 is equal to theta 0 minus alpha into, it will take the partial derivative with respect to the theta for the cost function, theta 0 and theta 1. Okay, so in the same way it will update the theta 1 also. Theta 1 is equal to theta 1 minus alpha into partial derivative of the theta with respect to the cost function. Okay, so now if you can able to see, there are the means we can able to see there are the some of the new terms are there. So first thing is this is the alpha. Okay, so this alpha is nothing but the our learning rate. Okay, so this alpha will decide like how many steps it will take toward the global minimum. Okay, so if the alpha is too large, so it is called as the aggressive gradient descent, in which it will take the large steps. Okay, suppose initially if we initialize the random theta here, so it will take the large steps like this. Okay, and if we keep this alpha is small, so it will take the baby steps, means very small steps toward the global minimum. Okay, so the reasonable choice of alpha is between 0.001 or 0.0001, okay, or 0.401. Okay, so that is the kind of the reasonable choice of the alpha. And whatever this term is there, okay, it is called as the partial derivative with respect to the cost function. Okay, so this term, like, we will see how we can able to solve. Okay, so this is kind of the derivative with respect to the cost function. Okay, so if I write what is the cost function for the square error function, so it is nothing but 1 divided by 2m summation of I is equal to 1 to m. Okay, then h of theta x of I, which is the prediction, minus y of I, which is the ground truth of square. Okay, so if we solve the derivative of this, then we will get the answer like this. Okay, 1 upon m summation of I is equal to 1 to m, then h of theta x of I minus y of I. Okay, we will get this. Okay, then now means this term we will get replaced by this when theta is equal to 0. Okay, so for the theta is equal to 1, at that time only we need to multiply, means this same term we need to use, but this needs to be multiplied by x1. Okay, whatever the currently associated feature is there, which is this, that we need to multiply, because here if you can see with respect to the theta 0 any specific feature is not associated, but with respect to the theta 1 we having the specific feature, so that feature only we need to multiply here. Okay, so this is for the theta 0 and this is for the theta 1. Okay, so if I replace all this term, then my final gradient descent, how actually it will look, so that I will show you. Okay, so the final gradient descent will be look like this. Okay, so this is repeat until coverage. Okay, and what I need to do, we need to update the theta 0 as theta 0 is equal to theta 0 minus alpha into 1 upon m. Okay, summation of I is equal to 1 to m, then h of theta x I minus y I. Okay, and in the same way we need to update the theta 1 also. So theta 1 is equal to theta 1 minus alpha into 1 upon m summation of I is equal to 1 to m. Okay, then h of theta x of I minus y of I into x1. Okay, so this is the simultaneously update actually we need to do. Okay, so the mathematically gradient descent for the univariate linear regression, it will show like this. Okay, so I hope you got the idea like what is the gradient descent. Okay. So here you just keep in mind, so gradient descent actually it is used to minimize the cost function. So how it will minimize? It will minimize by updating the parameters. Okay, and to update the parameters, this is the formula. Okay, so now we will go to the next. Yeah, so why the gradient descent is work? Okay, so this is very interesting topic. Okay, so yeah, so here again I will write the hypothesis function, like how actually we are getting the predictions. So hypothesis function, it is denoted as h of theta x is equal to theta 0 plus theta 1 x. Okay, so if you can see, these are the two parameters are there where our gradient descent will update these two parameter in such a way that the difference between that prediction and the actual ground truth, that will be the minimum. Okay, so for the simplicity, what I will do, I will make the theta 0 as 0. Okay, and I will just consider the theta 1. Okay, so our like after this updation, our h of theta x, it will become h of theta x is equal to theta 1 x. Okay, yeah, so this will become like this. Okay, so now what I will do now means I want, here I will give the justification like why the gradient descent is actually work. So for the simplicity, I kept the theta 0 is equal to 0, so this term gets cancelled, and the final equation actually it is become h of theta x is equal to theta 1 x. Okay, so here we will do the same. We will plot the cost function with respect to all the thetas, all the possible values of the thetas. Okay, so this is like the 2D graph. Okay, where your y-axis is the cost and the x-axis is the all the thetas. Okay, and our goal, the gradient descent goal, is to reach to the global minima. Okay, so why I am saying this is the global minima, because here the cost with respect to this value, okay, it will be the 0. Okay, means whatever the theta the associated with that value, that the cost will become 0. Okay, so with the gradient descent we need to come up with such value of the theta so that the cost becomes 0. Okay, yeah. Okay, so the first step of the gradient descent is like what? The first step is initialize theta randomly. Okay, so suppose in the first step this theta gets initialized to the this value. Okay, this value. Okay, then the next step of the gradient descent is like repeat until coverage. What we need to do, we need to update the theta 1 as theta 1 minus alpha into derivative, the partial derivative with respect to the cost function of the theta. Okay, so here only the one theta is there, so I kept as the theta 1. Okay, so now actually this, now I will use the different note pen color. Okay, so as I said, this is the learning rate, and this term actually what it will do. Okay, so this term, it will try to find the slope of tangent to this function. Okay, it will try to find the slope of tangent to this function. Okay, so how actually the slope we need to find. That is nothing but the height divided by width. Okay, so if here you can see this height is the positive because it is going from here to here, and the width also it is positive, okay, because it is going from here to here. Okay, so I can say whatever the value we will get here, this is the some positive value, right? It will some positive value we will get. Okay, so like what actually we are doing then here means we are updating the theta. Means what we are doing, like whatever this current theta 1 is there, which is nothing but this point. Okay, we are updating this theta by whatever the learning rate into some positive value. Okay, means from the current value we are subtracting some positive value. Means we are from the current value we are subtracting some positive value. Okay, means we are going from, we are getting some subtraction. Means from this to this direction actually we are going. Means the theta is updating from, means from the current theta we are subtracting something, means it will go backward like this. Okay, so this process will get repeat until coverage. Okay, means it will continue these steps until it will reach to the this point. Okay, so once our theta 1 is updated to this value where the cost it is become 0, so at that time what will happen? So here again we need to compute the theta 1. Theta 1 is equal to theta 1 minus alpha into derivative of the cost function. So this cost function, what actually it is doing, it is trying to find the slope of tangent to this particular function. Okay, so because of here the slope will become 0, because here the no slope we can't able to find the slope, because this one is the parallel line will be there. Okay, we can't able to find the slope for this. So once the cost will become 0, then this value it will becomes 0 and this theta will never update. So once we will reach to the global minima, then automatically we can able to go, or we can able to break that particular loop where we are doing the repeat until coverage, and we can able to find the global minima and optimal values of the theta where the cost is becoming 0. Okay, so because of this particular arrangement, this gradient descent, that whatever the formula which I told, because of this it is working properly. Okay, so now you having the question like because of the theta is means the randomly we are updating here, so because of that we can able to get to this point. But what if the theta is updated this side? Okay, means random theta is generated this type, this size, this side in the step 1. Okay, so at that time I will give the illustration again. Okay, so in this time what will happen? Okay, so in the same way, suppose this is our the cost y-axis, this is our x which is the theta. Okay, this is the cost, and this is our the cost function. Okay, so at the first step, suppose the theta is gets randomly initialized here. Okay, then in the second step, what in the same way we will do, theta 1 minus theta 1 is equal to theta 1 minus alpha into derivative of the cost function. Okay, so this term, what actually it will do, it will try to find the slope of, sorry, 1 minute, it will try to find the slope of tangent to this function. Okay, it will try to find the slope of tangent to this function. Okay, So now if you can see, this is the positive value, okay, but here this will become the negative. It means whatever the width will be there, it will become the negative. So the slope of tangent to this function, which is nothing but height minus negative, okay, this will positive, this will give some negative value, okay, this will give some negative value. Okay, so here actually what we are doing internally, theta 1 is equal to theta 1 minus alpha into some negative value. Okay, so here minus minus will become the positive. So what actually we are doing, theta 1 plus alpha into val. Okay, means whatever the current value of the theta, we are again adding some of the value in that current theta. Means we are going forward, means from here we are going like this. Okay, so this process again it will repeat until coverage, until it will reach to this point, and it will get automatically stopped, because when the cost is equal to 0, we can't able to find the slope for that, and the theta will not update further. Okay, so because of that, it is not depends on the whatever this randomness of the theta. Means if the theta, if it is initialized anywhere, we can able to reach to the point where the global minima is there with the gradient descent. Okay, so you can see how smartly actually they designed this algorithm. Okay, so I hope you got the idea like how the gradient descent is work. Okay, so yeah, so this is kind of very informative. Okay, like yeah, so some of the interview may ask this question, like why the gradient descent will work. Okay, so now let's see the next topic, like the choice of alpha and the convex function. Okay, so as I said, like suppose this is your y-axis, this is your x-axis. On the x-axis all the thetas are there, and on the y-axis your cost function is there. Okay, so if you choose the value of alpha is too large, okay, so at that time what will happen, whatever your cost function will be there, okay, and if you choose the value of alpha too large, so at that time I will use the different color. At that time it will may overshoot the global minimum. Okay, suppose this is your global minimum, but because of the large value of the alpha, it will take the large steps, means these steps, then these steps, okay, then again these steps, then again these steps. Okay, so it will may overshoot this global minimum. Okay, it will never reach to this point. Okay, so because of that, keeping the large value of the alpha is very bad choice when you are training your model. Okay, so how, like we need to do, we need to choose the alpha value, okay, the small. Okay, like the alpha value, the reasonable values of the alpha is 0.01, 0.001, okay, then 0.0001, okay, some of the cases 0.401. okay, so this range is the reasonable values of the alpha. So because of that, what will happen, whatever your gradient steps will be there, they will take the baby steps toward the global minimum. Okay, and at such point they will reach to the global minimum. Okay, so because of that we need to choose the small values of alpha. Okay, so yeah, so then the next is like, what is this convex function? Okay, so whatever the linear regression when you are using, so at that time whatever your cost function will be there, it is always into the ball shape. Okay, means it will always into this kind of the shape. Okay, okay, this kind of the shape, and there will be the only one global minima. Okay, there will be the not local minima will be not there. There will be only one global minima. So whatever this function is there, it is called as the convex function. Okay, and this convex function we will get when we are dealing with the linear regression only. But in the case of the neural network, or in the case of the very complex functions, okay, so at that time we will not get this kind of the function. We will, means there will be the many local minimas will be also be there. Okay, so yeah, so this is about the convex function. Okay, so now let's move to the next topic, which is the multivariate multivariate linear regression. Okay, so here needs to be regression. Okay, multivariate linear regression. So whatever the things now you saw, it is the univariate. So as I said, the term uni means one feature, and term multi means whatever this term it is there, the meaning of this, there will be the feature greater than 1. Okay, so in the same way, like we can able to see the same cost functions will be there. Okay, and the same gradient descent will be there, but now it will apply to the multiple features. Okay, so here the example of the multivariate linear regression, if I give into the this house price prediction. So suppose in order to do the house price prediction, you having, means initially you having just the size of house, right? This feature only you having. But in the multivariate linear regression, it may be number of bedrooms will be there. Okay, then it may be number of floors will be there. Okay, then it may be the other features like is parking available. Okay, like that many more features will be there. Okay, so in this case it having 1 2 3 4, so it having the 4 features, x1, x2, x3 and x4. Okay, and with respect to that we having the price of house, this will be the y1. Okay, this will be the y1. Okay, so there will be the multiple such features will be there. Okay, like this is the example, this is the feature, and this whole feature, okay, this whole feature will create one example like this. Okay, so this notation is for the telling us, like this notation is for denoting the example. And if I said x1 of 1 means I am denoting the into the first example, first feature, which is the size of house. If I tell you like x1 2, then into the first example, second feature. Okay, and if I am telling x1 3 into the first example, I am showcasing the third feature, means this one. Okay, so like that there will be the n features will be there. Okay, n features will be there. So this is just the notation to understanding like how the gradient descent for the multivariate linear regression will be work. So in the same way the algorithm is same only, like for the gradient descent. Okay, so I will use the some different pen. Okay, so for this, the gradient descent algorithm, how it is, in the same way this is also repeat. Okay, repeat until coverage. Okay, and here, okay, so here for the simplicity, what we will do, we will keep this x0 as the 1. Okay, so we can say that theta j is equal to theta j minus alpha into 1 upon m summation of I is equal to 1 to n, then h of theta x of I minus y of I, okay, into this is important, which is nothing but xj. Okay, and your j will be ranging from 0 to n. Okay, so in the case of theta 0, so because of we kept x0 as the 1, so this will not affect, means whatever the value into 1, this is become 1 only. Okay, and in the case of the theta 1, it will take this value properly in order to multiply that. Okay, so this is only the change into the, means not change, but this is only the kind of the setting inside the multivariate linear regression gradient descent. Okay, so I hope you understand this thing also. Okay, so now the next topic is, yeah, so this I already covered. Okay, yeah, so so for now these are the topics actually I prepared. Otherwise this video will get more long only. I think already more than means close to the 1 hour actually we spend this session. Okay, so we will go to the step by step. Okay, we will try to understand all the things into the step by step. Okay, I don't want to feed all the things into the one time, so it can be difficult to understand. So whatever the topics which we discussed in this session, I want you to go through that. Okay, again, just take the revision or just check like what and all the things are there. Okay, and don't forget to subscribe my channel and press on the bell icon. Okay, thank you so much. So into the short time I will come with the next part, okay, where I will cover the next topic for this machine learning section. Okay, thank you so much.